Okay, this is just a short presentation on how carbon dioxide can be extracted from the atmosphere and converted into useful produce and products. This is basically a summary right here of what my presentation is going to be about. Feel free at any time to pause and take a look at any of these. I won't go into each of the steps in more detail as I progress. So step 1 is a method by which the carbon dioxide can be extracted from the atmosphere. Now this particular method is done by a company called Carbon Engineering. It has a liquid solution that actually bonds with the carbon dioxide in the atmosphere, and it uses a honeycomb system with what is essentially a giant extractor fan to pull the air through the honeycomb system, and the liquid is run down through it. The carbon dioxide bonds to it and is gathered below and is contained. It can later be separated using a high degree of heat and put into a container. Now, carbon engineering itself actually uses the captured carbon dioxide to convert it back into fuel, which ultimately just ends up putting the carbon dioxide back into the atmosphere, which is redundant and will not do anything to help reduce climate change or the amount of greenhouse gases in the air. But the carbon capture system itself will be extremely useful, and it can also be connected to exhaust from fossil fuel power plants to capture the carbon dioxide from that. It would take a bit of work, alright, but the carbon dioxide could go directly through the system and be captured before ever released into the atmosphere. Now step 2, this is the process of pyrolysis. I might be pronouncing that wrong, I don't know. This is a method by which waste plastic or end-use plastic that is not suitable to be recycled can be converted into fuel. It involves heating it in a reactor that is absolutely oxygen free. If oxygen is present, it would just cause the plastic to burn, but without oxygen it causes the molecules to break apart back into the base component, which is basically the same as petrol or gasoline or whichever you want to call it. So this method here can be used to clean up the amount of plastic that has been dumped in our ecosystem and provide a fuel that can be used to provide heat for separating the carbon dioxide from the liquid solution, and the fuel can also be used for the heat for this system as well. And of course power can be generated as well if set up properly. And all the carbon dioxide from this can be run through the carbon dioxide capture system and stored, so it does not be released into the atmosphere. So this has a double benefit of cleaning both the waste plastic and the carbon dioxide out of our ecosystem. And of course this can actually be used in fossil fuel power plants as a different fuel source, so we don't have to be reliable on getting oil. So both these things can be used together to turn power generation fossil fuel plants into not only generating power but cleaning up the ecosystem instead of damaging it. Now the third step is actually the most important, is what to do with the carbon dioxide once it's captured. Now this process can convert carbon dioxide into carbon nanotubes. It's a very valuable and useful molecule, and it has been found to be a lot stronger than steel and extremely versatile in regard to conductivity for electronics, into strength for making products and things. They're still even working on what can be done with it. They even lately are working on making transistors like about 1/5 the size of the smallest that's currently possible, so it can make computers a lot more advanced. I don't even know if they're finished even thinking about the amount of products that can be made with this. So all the carbon dioxide can run through this process and turned into carbon nanotubes, even just stored for later use, but it can be used straight away. Instead of storing the excess carbon under the ground, it can be made into this valuable material that has abundant uses, and if you're considered about economic cost, this material is actually worth a lot. I do not remember the exact value, but I will be sharing a video for every single step that I'm doing here, and I will give a video about what carbon nanotubes are, and it should say about the current value of them. So step 4. This is a process that was developed by Rice University in Houston, Texas. Being able to combine the carbon nanotubes into a continuous filament, or a string, as you can see here. Well, it can be woven into materials, it can be made into wires, and it can actually be used for making a form of carbon fiber. The carbon nanotubes are a lot stronger than the carbon usually used in carbon fiber products, so it results in a superior quality carbon fiber. It's a lot stronger, more resistant. Now, this is just a little screenshot of the Mark IV X7 3D printer, which is capable of printing carbon fiber products. So the continuous filament can actually be turned directly into carbon fiber this way and just assembled. You can make abundant designs for products, from even things like bicycles, tennis rackets, outer casings for all sorts of things, but it can be scaled up for creating vehicle components such as the chassis for cars. You can make even individual components like the axles. Nearly pretty much anything you can make from metal and steel on a vehicle can be made from this, and scaled up sufficiently can actually be used to make components for buildings, due to the fact that this carbon fiber would be stronger than steel and actually superior to steel in a lot of ways. Now this is a picture of Jack Fresco's work in the Venus project. He recently won an award from the UN for city design, and it's just a concept of the type of things that we could be making by converting the carbon dioxide into carbon nanotubes and just 3D printing it into things. So we could actually work on designing sustainable cities, sustainable architecture, and the fact that we'll be storing it in buildings. There are millions of tons of carbon dioxide being produced every year, put into the atmosphere, that need to be extracted to get down to pre-industrial levels and make the Earth safe from the disasters that will cause climate change. So this here is just the kind of thing that we could aim for, and that we should actually be thinking about in the long run, because we need to have sustainability in every level. It's just senseless not to do it at this stage. Now, just to elaborate a bit on scaling up, this is an example of a 3D printer designed to print an actual house entirely from concrete. It's just in action here, and as you can see, it just prints out the concrete on a big scale. I've seen a video of showing how in China they can print one house every 10 hours. There are different designs than this now, but this just shows the process and shows how these things can be scaled up. And the final slide here in my presentation is it's a product called Ultra Everdry. It's a treatment that can be put on nearly any surface to make it completely frictionless and non-stick. As you can see here, this is just plain water. It's just dribbled along, not even wetting the surface. This could be applied to molds, because 3D printing often doesn't have a smooth edge on the edge. So when 3D printing carbon fiber to build housing, it can be done such as flat packs from, say, Argos or IKEA, and assembled on site, having the perfect smooth finish because of the mold for the outer shape. Everything can fit together, and you apply resin in between the parts when you're like screwing and such, just to hold things. Apply resin as kind of a glue and sealant to hold it all together. It can just be like an outer shell, an inner shell, a gap in between with a support structure. It can be filled with concrete then on site, and you can make advanced buildings without needing steel support, because the carbon fibre made from carbon nanotubes would serve that purpose and even better than before, and having the two outer layers would protect the concrete from any wear and tear from environmental things. So that is actually the end of my presentation. I will also include a little video about a product of highly fire resistant carbon fibre that shows how it can be quite useful for housing, since you do want fire resistance for housing. So thank you very much for having a look at this, and I hopefully will have some more videos soon in the future. Okay, the end. Bye.